It's another day that you want to learn about a few things here and there in chemistry. And so the topic of specialization is structure of the atom and the periodic table. And we want to start with a few things here and there for making up a review. And the essence of this class is to make those learners that when they are in class, they don't get everything right, or just maybe it's a part of revision work. So it's just to help students revise and prepare for exams efficiently. So I will start with isotopes, and then we look at how to calculate relative atomic mass given a number of isotopes. So what we shall begin is to define what is an isotope. And an isotope or isotopes are atoms of the same element that have the same atomic number but have different mass number, and this is due to the difference in number of neutrons. Have a different number of neutrons. All right. So just a review before we go to the main aim. The number of protons in an element, which we are calling atomic number, and the number of neutrons in in an element, which we are calling the neutron number, are summed up so as to give you the mass number. And in simple terms, I can say mass number is the sum of number of protons and the number of neutrons in an element. Now we move to what was the topic of the day, and it was how to calculate the relative atomic mass of an element given isotopes of that element. And when we start, so the task is how to calculate the relative atomic mass, which we are calling the RAM, given two isotopes. Just to begin with a few things, relative atomic mass is calculated by taking the product of mass of the isotopes and the relative abundance divided by 100. I repeat, relative atomic mass is calculated by taking the product of the mass of the isotope and the relative abundance divided by 100. I think the point there is clear. So the example we shall handle is, maybe you can just take a question from the KLB, Chemistry Form 2, where the question says, if you can write well, but if my speed will be too fast, then in my next class I may display a video, or if you request me, I may explain and send you the handouts after the class. So the question is, chlorine has two isotopes. Chlorine has two isotopes. chlorine 35 and chlorine 37. Chlorine 35 has a relative abundance of 75%, while chlorine 37 has a relative abundance of 25%. So the question is, calculate the relative atomic mass of chlorine. Question is, calculate the relative atomic mass of chlorine. So my viewers, the question is clear as it is. How do we do it? We shall begin by saying the mass, we have them. So the mass of that chlorine 37 is 37. The mass of chlorine 35 is 35. And from the question, the percentage abundance of chlorine 35 is 75%. And that of chlorine 37 is 25%. So how do we do it? I've said relative abundance is relative atomic mass is calculated by taking the product of the mass of the isotope and the relative abundance and dividing it by 100. So if we have mass, we have relative abundance, and then we shall calculate as follows. Starting with chlorine 35. Chlorine 35 has a mass of 35 and relative abundance of 75. So we shall take RAM is equal to 35 times 75 all over 100. 35 times 75 all over 100. And 35 times 75, we get 2,625. I think that is clear. 2,625. So when you divide by 100, you get 26.25. 26.25. On the other hand, we have 37 times 25, which we are getting as 925. When you divide by 100, you get 9.25. So we have the mass of chlorine 35, which is 26.25, and the mass of chlorine 37, which is 9.25. So the RAM of chlorine will be the sum of the two answers, which is 26.25 plus 9.25, where the final answer is 35.5. So the RAM, which the relative atomic mass of chlorine, is 35.5. Remember, relative atomic mass is a ratio, and therefore it doesn't have units. Thank you. For more, you can subscribe at my YouTube channel. You'll get the link. Thank you. Goodbye.